this edition of India Means Innovation, where we discuss the technologically complex innovations coming out of India. Today, we are talking to Suraj Rengarajan, who is the head of the Semiconductor Products Division at Applied Materials here in Bangalore. Applied Materials is a $26 billion company that makes products that go into manufacturing of semiconductors.
Yes.
Welcome, Suraj.
Thank you. Thanks, Aditya.
The world is running on semiconductors, and the making of semiconductors is an incredibly complex process. And lithography is one of those critical parts of the process. So, Suraj, can you explain what exactly is lithography?
So, lithography is a very critical step in the making of a semiconductor chip. So, lithography essentially defines the critical dimension, the smallest dimension that you can fabricate in a chip, and that defines the performance of the chip.
And what is the challenge that was defined by your team out here?
So, today chips, advanced chips are made in the nanometer scale. To make chips at the nanometer scale, there is a new lithography technique called EUV, extreme UV. And those machines run about $150 million and are one of the most costliest part of the semiconductor value chain. Because of the cost involved with making these very small dimensions, if you keep scaling down, the cost has started going up, right? One of the ways to get this performance back is to make innovations on the packaging side. How you put it together, you can get performance from that which you would have otherwise got from shrinking the dimension. So the inflection or the challenge that we are addressing today is how can I get performance for my advanced packaging, the lithography element, without having to use the costly part of the lithography that is applied in the advanced node of chip manufacturing. This does not require nanometer scale critical dimension. You can do the same with microns, about 5 micron critical dimension. So the question is, if you are going to get performance improvement from packaging and you do not need nanometer scale, you do not need the kind of lithography tools that you're using for advanced nodes, you can use a different kind of technology to be able to get micron scale dimension and get performance through the advanced packaging.
And this different technology is the digital lithography tool that Applied Materials has created here in Bangalore.
Yes, absolutely. So this is a technology called digital lithography, and in the digital lithography, so imagine that you have a stencil that can be configured on the fly. So you have A, B, C, D and you want it to be A, B, D, C. You can reconfigure the stencil and have it such that you can direct write whatever you want using this stencil. So the digital lithography technique gives you the ability to quickly reconfigure to get the pattern that you want on your wafer or on your substrate in a cheap and economical fashion. That is the innovation that this center has done.
And this entire thing has been done by the team in Bangalore.
Yes, all of this requires mechanical engineering, it requires systems engineering, and it requires the ability to have these mechanical engineers, software engineers, electrical engineers, architectural engineers to be able to talk to each other and come up with a solution. Then you need to make this. So this team has done all the above. They took this idea, then they made it into a prototype, then they made a system, and that system has now been commercialized.
And it has been commercialized globally?
It has been commercialized globally. We have more than 10 of these currently in R&D testing at our major customers.
And the entire design and architecture and the conceptualization, everything has been done at the R&D center here in Bangalore.
Yes, everything regarding this has been done here, and the ownership of that product also resides here, and the team is now looking at how they can also support the proliferation in the field.
So this is a great example of India means innovation.
Yes, it is.
Wonderful, wonderful talking to you, Suraj. Wonderful hearing about this great innovation. Thank you.
Thank you.